Geothermal energy is globally recognized as a clean and reliable baseload power source.
It's not like hydro. Hydro, if we have a dry year and just 1 meter, whatever, all our hydro power plants will be shut down. But not with geothermal. So it's good for baseload.
In East Africa, Kenya is leading the way with over 1,000 megawatts of installed geothermal capacity.
Kenya geothermal represents over 50% of our electricity production. As you all know, Kenya's grid is over 90% green, and this has largely been contributed by geothermal power. We began our geothermal journey way in the 1950s, where we drilled some 2 wells in the 1950s. They were not productive, but throughout the years we have learned so much about geothermal drilling to the point where we are at actually we are about 1,050 megawatts of geothermal energy.
Uganda, like many developing economies, is navigating a dual energy challenge, delivering clean, reliable and affordable power to sustain rapid economic growth while addressing the impacts of climate change.
We must respond effectively to climate change by reducing greenhouse gas emissions associated with energy production and consumption. In response, the government of Uganda has committed to a deliberate energy transition pathway, one that prioritizes sustainable, low-emission energy systems while ensuring energy security and economic competitiveness. Geothermal energy is central to this transition. This is because Uganda is endowed with significant geothermal potential.
The Regional Geothermal Development Meeting in Kampala, which has brought together experts from across East Africa, is seen as a critical platform for strengthening collaboration in unlocking Africa's renewable energy potential. The meeting has also provided an opportunity for regional stakeholders to exchange knowledge with the French delegation keen on exporting geothermal expertise.
I mean, in France, actually, we have been developing what we call district heating since over 50 years. I mean, that's probably what we can bring, which is the most significant. Like knowing your resource, each country knows its own resource. And we cannot do better than local people to know the geothermal resource. But what we have probably that makes our difference is that we have been taking heat to heat, because we are a cold country, so to heat the building and houses. We have been doing that over 50 years, and so we have a long experience in that. And we have a long experience in managing geothermal resources.
In France, in eastern France, we also have rift system. So it's a geological structure that is pretty similar to what we can find here in Uganda, and there are some seismic activity risks.
Advanced geothermal investigations in Uganda have identified several promising prospects, including Kibiro in Hoima District, Panyemur in Pakwach District, Buranga in Ibundibujo District, and Katwe in Kasese District.
Our potential, or the estimated potential, is 1,500 megawatts for electricity generation, up to 6,000 for direct heat application. So we have one which we estimate at 1,500 megawatts for electricity generation, but also for the direct heat applications is 6,000 megawatts.
The delegation have visited Kibiro and Panyemur for a fact-finding mission. Despite an estimated potential of over 1,000 megawatts, Uganda is yet to generate electricity from geothermal resources, raising questions about the pace of development.
It has taken us long. Geothermal exploration and development is costly. It's costly. One well takes $5 to $7 million US. We need like 8 wells at the beginning. So one of the major reasons is the high risk, the high cost of geothermal development. And unlike other energy sources, for hydro you can do the feasibility within 1-2 years. But this high cost, you need the drilling into the reservoir, which is 3 kilometers. So it's a lot of, and not many private players are willing to come in before you de-risk I use the word de-risk, remove the risk. The second reason is the risk. The other one was cost. Then the second is risk. Those countries which have developed geothermal, they have drilled several dry wells. I mean, you find nothing.
Government now says efforts are underway to move toward commercialization with a target of generating at least 50 megawatts of geothermal power by 2030.
Successful development of geothermal energy requires more than resource availability. It demands strong institutional framework and skilled human capital. In this regard, the government has taken deliberate steps to strengthen the enabling environment, and this is the regulatory framework.
Geothermal energy is a reliable 24/7 renewable resource used in electricity generation, heating and cooling and industrial processes. Its applications range from powering turbines using underground steam to supporting greenhouse heating, crop drying and aquaculture. Dennis Igoa for UBC.